So class, in last two videos we have discussed definition of distance and displacement and their example. In second video I have discussed difference between distance and displacement. In this video I'll discuss about uniform non-uniform motion. You must consider this an arbitrary example that Virat Kohli makes 5 runs in first over. As you can see in the video, I have written case 1. In second over 2. In third over 4. So, in second over, total run, wait for a second. Yes, sorry for the delay. In second over, total run are 7, and in third over, total runs are 11. 5 plus 2 plus 4, which is equal to 11. If I draw a graph between runs and over, it will look like this. We always take variable quantity on y-axis and constant quantity on x-axis. First over, in first over, run were 5, so point will be here. In second, total runs were 7, so the point will be here. And similarly for third over, total runs were 11. So that's why if I connect these all points, it won't look like a straight line, it will look a curved. This type of graph is called non-uniform. Now consider second case in which Virat Kohli makes 4 runs every over. So in first over, total runs are 4, in second 8, and in third 12. So again I make a graph between runs and over. It will look like this. For first over, the point will be here. For second, it will be here. For third, it will be here. If I join all these points, then I get a straight line. This type of graph is called uniform. Take another example in which you are going to Jaipur from Panipat. In first hour, you cover 50 kilometer, as you can see here, 50. In first 50. In second hour 100. In third hour 150. Again I draw graph between distance. Here I will draw graph between distance and time. It will look, if you draw your graph yourself, then you will get a straight line like we have done in previous example. So this type of motion is called uniform motion. So in PDF you will find this definition that an object is said to be in uniform motion if it covers equal distance in equal interval of time. See here, equal interval, I am taking 1 hour, 2 hour, 3 hour. I am not taking 1 hour then 1.5 hour or 1.8 hour. I always take 1 hour difference. So that's why I have included equal interval of time. And equal distance, in first hour you have covered 50. In second hour also you have covered 50. But a total distance you covered in 2 hours will be 100. So that's why we define uniform motion is like this, that a motion in which an object covers equal distance in equal interval of time is called uniform motion. This is almost impossible because when we go anywhere we find people or animals or anything on road, we slow down our speed and we cover less distance as compared to a situation where there is no crowd. So imagine in first hour, when you are going to Jaipur, you cover 40 kilometer. In second, 100. First 40, in second 100, and in third hour 120. So if you make a graph between distance and time, it will come like this, a curve. So this is the basic difference between uniform and non-uniform motion. Now you can define non-uniform motion. Just change this word here, put unequal here, and rest of the words remain same. So you can make the definition by your own. If you know the definition of uniform motion, an object is said to be non-uniform motion if it covers unequal distance in equal interval of time. So this is a basic difference between uniform and non-uniform motion. So now I will explain scalar and vector quantity. This is the same thing which I have explained earlier, distance and displacement. You can read this and you will get to know what I have written here. But there is another example which I want to explain about distance and displacement. See here, a right angle triangle ABC, this. If I say I want to go to A to C, from how many ways I can go there? First I go to A to B, then B to C, or I can directly go from A to C. So in this case, my shortest distance is AC, so I'll make AC displacement and AB plus BC as distance. So this is from here, this example I can say that value of displacement depends on direction. Here you take this direction, here in second case you took this direction, and that's why you have written AC displacement. So displacement depends on direction, but distance does not depend on direction. I'll explain more example of it. First of all, understand what are scalar quantity and vector quantity. Scalar quantity are those quantity which have only magnitude. Magnitude means 1, 2, 3, any natural number. And vector quantity are those quantity which have magnitude as well as direction. If we define any quantity with magnitude as well as direction, then we say that quantity as vector quantity. Like, see this, in displacement direction matters. I'll explain how. This is a line. This is A point and this is B point. You're starting your journey from point A. First you go to point B, and then you come to point C. In this case, as I have explained this example earlier, AC is displacement. And AB plus BC is distance. So, as you can see that you did not consider BC in displacement. You only consider initial and final point. Although you have gone to first B and then come to C. So it means that you have subtracted how you get AC. AC is equal to AB minus BC. I can write this. So this minus indicates that you change your direction. Means first you are going towards right, then you came back, then you are coming to point C. Means towards left. So here I am discussing about right and left. What they are direction. That's why displacement is a vector quantity and distance is a scalar quantity. In distance I only write plus sign. It doesn't matter in which direction you are going, distance just add up. Whereas in displacement we consider negative point, negative sign. When you go towards right hand side, you introduce plus sign. When you go towards left hand side, you introduce minus. That's why displacement is vector quantity. In difference also, I have written second point that displacement is a vector quantity, whereas distance is a scalar quantity. I hope you understand this point.